Hello everybody. In this video, we will see how to take the first steps in RobotStudio. For this, we will make a small test and we will see the different options that the interface gives us. The first thing to do is to open the application. First, we will check that we have the license activated. To do this, click on Options. Then click on Licenses and check that the following features are active. If for some reason, we do not have any license, we will have to click on Request a License. Then, under Network Licenses, choose the first option, and click Next. On this page, you will have to enter your code. In this case it is hidden because it is the school license. If you have any doubts, ask your teacher. Once the license is verified, the first step is to create a station. To do this, select an empty station and click on Create. The first step is to add the robot. Click on the AB library. Inside, we will select the robot that we have. In this case it will be an IRB 120. If we click Ctrl plus Shift plus the right button, we will rotate the view. On the other hand, if we click Ctrl plus Shift plus the left button, we will scroll the view but without rotating it. With the scroll, we will zoom. On the other hand, if the robot is not in the desired position, we can position it in another place. To do this, right-click on the robot and select Position and then Set Position. By means of the coordinates, we will be able to place and rotate the robot where we want. In this case it will be with respect to global coordinates. If the position is not specific, and is not important, we could do the following. In the top tab, select the Move option. 3 axes will appear, and by pulling from one of them, we can manually position the objects. To move it back to the initial position, we would do the following. The next thing to do is to put a tool on the robot. In the top left corner, select Import Library and then Equipment. Here we will find different elements. At the bottom, we will find a section called Training Parts. Here we will select My Tool. Now we have to position it at the tip of the robot. To do this, in the tree we will drag the tool over the robot. The next step is to insert the virtual programmer. Without it, we will not be able to program anything, nor simulate on the physical robot. To do this, select the Virtual Controller tab. Inside, click on Design. In the section of Robotware, we will select this option. In this case, we have only one case, but it is possible that several appear. In this tab, we will wait until the Options box is enabled. Click on Options. You will always have to do this step to use the flex pendant. It is a screen that is used to program the robot at the machine. Inside Options we will select the language. In this case we will select Spanish as the second language. If we do not do this step, the flex pendant will be only in English. We will have to wait for the controller status to be green. At the top left, in the tab Trajectories and Points, we will see that we already have the controller. Within Work Objects, we will have a Work Object. By means of this we can program points and positions of different elements. To give the robot different poses, we can do it manually. To do this, click on the Freehand tab, under the Reorientation Movement option. We can see that the turns we make are with respect to the flange of the robot, where the tooling is attached. We want the reference point to be the tip of our tool. To do this, in the Parameters tab, under Tool we select Mu Tool. Now we can see that the turns are made with respect to the tooltip, keeping it always in the same position. Now, we will learn how to position the tool tip in the desired position. In this case, I will place it in the previous position that the program gave me by default. To do this, in the left tab, right-click on the robot. We will select the option Transfer to Position, and inside it Initial Position. As a first example, we will make a program where the robot will draw the geometry of a cube. For this, we will put an object with the shape of a cube. Inside the section of Modelado, we will click inside Solid and then Tetrahedron. We will be able to set the dimensions of our object. In our case it will be a cube with sides of 300 mm. Its position would be 300 mm on the x-axis, and minus 150 mm on the y-axis. In this way, we would leave it centered. The next step would be to obtain the points we need to draw the square. To do this we will go to the Program Position option. Each time we click on this tab, the program will save the point where our tool is located. This time we will save the initial point. To make sure we don't make a mistake, we will change its name. Right-click on the point and select Rename. We will give it a more meaningful name. In this case we will call it House. To get the different points we need to make the square trajectory. The interface offers us a very easy way. At the top of the screen, click on Snap to Objects. This way, we can select all the corners of the objects and save them as points. To move the robot to these points, we do the following. In the Linear Movement section, click on Linear Movement and select the tool. When moving the robot, the program will automatically move the tool over the points of the object. Once the robot is positioned, save the 4 points. To do this, move the robot to the desired point and click on the Position program. You can see that the programmed points appear inside the work object. When we have all the points, we will make a trajectory that joins all the points. To do this, click on the Trajectory folder and select Create Trajectory. To add the points, select all the points and drag them into the path. We will also be able to order the path of the points. In my case, the path will have to start from the home point and go all the way around the perimeter of the cave. As you can see, the robot goes through all the points but does not close the figure. For this we will add again the point of the first corner and we will drag it to the path. Likewise, as we want the robot to be in a safe position at the beginning and at the end, we will add the home position at the end. To verify the operation of the robot, we can see the movements that the robot performs. To do this, right-click on the path and select Move along the path. This way we can verify that the robot makes the right movements. The points we have selected are not yet part of a program. To save it as a program, we have to do the following. At the top of the screen, click on Synchronize, and then click on Synchronize with Rapid. Select all the possibilities. Now we will go to the Rapid tab. Rapid is an interface where we can directly program different instructions using structured text. On the right side you can find different folders. In one of them is the path we have programmed. If we click on it we can see the code. To simulate the code, go to the Simulation tab. Click on Simulation Configuration. We select among the controllers in TROB1 and as entry point, we will put the program that we want to simulate. In our case, we will choose the main program. Then we will click on Update and finally on Play. We will see that the robot has not made any movement. This is because inside the main program we have not made the call to the subroutine of our trajectory. For it, inside the main we will call to our function path 10. If we write it twice, the robot will run the program twice. Now we will see if what we have simulated works. You can see that it's done it twice, as many times as we've defined in Rapid. If we had defined as entry point only the path instead of the main, the simulation would only perform the path 1. In this video we have programmed all the points one by one manually, but there is also a way to do it faster, using the option to create point. In this way, instead of going one by one, what I do is to enter all the points at the same time. To do this we click on Create Point, and with the help of the cursor we select the desired points. In this case, the corners of the curve. Once selected, click on Create. We can see that inside the work object, the points have already been created. As before we have taken the robot to the point, when we have saved, so has the position it had at that moment. In this case, the robot has not saved the orientation of the tool with respect to the point. To see it, click on the point and select View Tool in Position and View Robot in Position. As we can see, the tool aligns its axes with the axes of the point. If we keep this position, the robot will not be able to reach it, so we will have to reorient the tool. To do this we do the following. Click on the point and then select Rotate at the top. This should be done with respect to the local base. We will rotate the tool until we see that the robot is able to reach it. This way we can change all the orientations one by one. There is also another option. If we like the orientation that the robot has in one point and we want it to have that orientation in all the points, we can copy its orientation and paste it to the rest. To do this, click on the point we like its orientation and select Copy Orientation. Select the rest of the points and apply the orientation. This way we will have the same orientation. It is important to see that the robot is able to reach all the points. What we don't know, and it happens many times, if the robot is able to do the trajectory in spite of being able to reach the points. The robot is able to reach the program points independently, but it can happen that the robot is not able to chain them together in a trajectory. To verify this, we will simulate it. First we will create the trajectory. As we have done previously, we will select the points and put them in order. To see, click on the path and select Move along the path. We can see that there is no problem. If there were any errors, we would have to analyze different ways to position the robot and reach the point. With that problem we will make another video to analyze it more deeply. I hope that with this video you will be able to take the first steps. If you have any questions, don't hesitate to ask me. Thank you very much and see you in the next video.